from the Department of Electronics and Computer Engineering, Walchand Institute of Technology, Solapur. Today, we'll be continuing with the online EDA tools that we started the discussion earlier, and according to the different tools available, we had started this particular journey using Tinkercad. Now, in that particular tool, we'll be continuing with this particular video in utilizing the online EDA tool for interfacing of button and LED. Similarly, the upcoming video will demonstrate about the interface of LDR, that is light dependent resistor. So to start with, very simple stuff, that we need to jump to the online tool, and as you can see it here, uh, you have to log in into the Autodesk platform called as Tinkercad. On that Tinkercad platform, we need to start with the interface. So I already completed the diagrammatical presentation as for explaining this particular concept of utilizing how to implement it. We'll need a special circuit where we have interfaced this particular thing. So from the diagram it can be seen now ki what we have here is the digital pin number 13 of Arduino controller is connected to the anode of the LED through the resistor, and similarly if we see it, there is a push button out of which terminal 2A and 2B are short by default, and 1A and 1B are short default. So we are utilizing the connection between 1A and 1B. This is a pull down resistor that is connected to the ground supply, and through this particular wire we are connecting it to pin number 9, digital pin number 9, and this is connected to VCC. Now whenever this push button is pressed, this particular 5-volt supply will be connected through this particular button short to the pin number 9, which will lead and make that particular pin number 9 as high. Similarly, when this button is not pressed, due to this pull down resistor, this particular terminal is at a ground potential. So LED is for indication purpose, and this particular push button is for the input. So input, and this will act as an output. The power supply for this particular double rail of breadboard is taken from the Arduino board itself, where this is taken from the 5-volt is in positive, and then the ground is connected from this. So overall, this is the diagram that we will be utilizing for this particular code. Now we'll jump to the code part. As earlier we have seen, this particular thing that we can utilize in two ways. One is in the toggle fashion, and the other one is in the form of as button is pressed, till that time this particular LED will be turned on. So to start with, a simple explanation for this, if we see this particular program, I will uncomment this part, and the other part I will comment it out, and I will explain both the codes. Now if we see it here, at very beginning we have taken this particular state variable for the purpose of toggling the LED state. So for timing we'll be keeping it as a 0. In first method we will not be utilizing this particular part. The LED built-in is your pin number 13, which is the built-in LED. We have taken it as an output where we have connected the LED. Pin number 9, where the input from the button is connected using the pull down resistor and the VCC combination. We have selected these pin modes, so we have made this as an input and the LED one as an output. After that, we are checking continuously in the loop the digital by digital read if this particular button input is high, like the state of the button, whether it's pressed or not. So if it is pressed, what will happen is the button is, if it is pressed, this particular condition will be true, and what we'll have is this particular built-in LED will be turned on. Now this particular delay is for to avoid the debouncing, so keyboard debouncing, avoid uh, to avoid that particular part, we have simply given a 100 milliseconds delay. If that particular button is not pressed, what will happen is by default this else part will be executed as the input at pin number 9 will be low, and that will lead to the LED will be turned off by providing digital write as a low. So if we try to run and start simulation for this particular program, what will happen is, if you see it, we are not pressed any button right now. Now if I press this particular button, you can see that the LED is turned on. Now if I leave this particular button, the LED is turned off. So I can turn on, and the moment I leave this particular button, so this is the logic, simple, to turn on and turn off the LED using the button. Now instead of LED you can use relay or any other device to turn on or turn off. But what is the logic here happening is until and unless I, or till the time I keep this particular button on, this LED will be turned on. The moment I will leave this particular button or push button, if I leave it, this particular LED is turned off. Now the other logic that I discussed was to toggle. So once if it is pressed, it will toggle the LED, and once it is released, it will again. So we'll stop the simulation first. So we'll stop the simulation, we'll comment out this particular part which is not required for the time being, and then we'll uncomment this particular part. Now in this particular logic, if you see it here, it is again reading the same button which is connected at pin number 9. Now here the value of the state at initially if you see, we have initialized it with the 0 value at the beginning. Now whenever this particular button is pressed, now this particular button is pressed, this particular state will change its state by toggling it. So negation is there, and it will toggle. If it is 0, it will become 1, and then so on and so forth. The next time it will. So again, to avoid the debounce effect and multiple time phrase, we have provided a 500 milliseconds delay, and whatever the value this particular state possess, either high or low. Now I will show you by scrolling it down. Now if you see it in the program, this particular digital writing, the built-in LED is provided with the state. So if state is 0, the LED will be turned off. If the state is turned on, like it will make it as a high. So that will give you the output. So if I run this particular simulation again now again the same stuff, there is look like no LED is on. Now if I press this particular button once, LED is on. Now you can see that I am not pressing this particular button by my mouse. I left that mouse as is, and this particular LED is turned on. Similarly, if I hit again, if I hit this particular LED, will be turned off. So to recap this, I will go through the program again and will let you know. So this particular part will toggle it. So this is the toggle operation of the LED. It's very simple, and we can check it out what exactly is the state of that particular LED. So if it is on, it will be turned off, and if it is off, it will be turned on whenever the button will be pressed. So we'll stop this particular simulation and we'll go through this particular program. If you see this particular program, this particular state variable is particularly taken for the keeping the state of that particular LED, whether it is high or low. The pin modes are for the capturing whether that particular pin of that particular Arduino is going to be output or input, that we have kept it in the setup part, and then loop part will run continuously. In the first logic, we have checked that whether the button is pressed, so that becomes in high. So whenever that button is pressed, till that time period, this particular built-in LED will be turned on, or it will be kept as a high, else it will be kept as a low. But the other logic that we built was this: if this particular digital read is high, for that particular button is pressed is high, then as per the value of the state, the previous state, whatever it has 0, it will be toggled to the other one. So if it is 0, it will be toggled to 1, and if it is 1, vice versa. So this particular state is assigned to the digital write of particular LED, and according to that, this particular LED will be turned on or turned off whenever the button is pressed. With this, the very first part we have finished in LED and button interface. Now we'll switch over to the other one. If you see, the first part we have finished, the online EDA tool to interface the button and LED. Thank you.